Good morning. All right, so we're going to pick up where we left off yesterday or Monday. This is section 1.5, still equations. And so we're going to continue to work on quadratic equations of different types now and look at different ways that we can solve, especially when we can't factor anymore, right? Because we looked at factoring in the previous on the previous day. So today we're actually going to look at some cases where maybe you can't factor, and then what could we do instead? Before we get started, though, just a couple reminders. Continue to work on homework. The 1.5 through the 1.10 homework is posted. Again, the goal right now is to try to get through the rest of chapter 1 by next week, and that way I can get that test posted and you can get that done. Just know, because I've started to kind of think ahead at this point, based off of where we are now, I'm going to have to start trimming some things as we move forward in other units. So my plan is to create videos for certain sections and then teach live other sections. So you'll still have me explaining things, right? But I won't be doing that on the Monday, Wednesday, Thursday that we meet necessarily. So maybe I'll cover material on Monday and Wednesday, post videos, a couple of videos for that week to get us called up. And then maybe Thursday is like a day for you to come and ask questions or something like that is what I'm thinking at this point. So you'll still have videos of everything, but everything won't be live once we get to chapter 2. Okay, so just so you're aware of that, that's what I'm thinking about for chapter 2. All right, any questions, comments, concerns, though, before we get started today? All right. So, like I said, this is still section 1.5. So now we're going to look at simple quadratic equations. And what I mean by that is anytime you have an equation in the form x squared equals c, where c is some constant value, some number, we can actually just take the square root of both sides of this equation, and we're going to get the two solutions, x equals square root of c and x equals negative square root of c. In other words, a way that we can solve an equation in this form right here is just to take the square root of both sides to get our x by itself. But when we do that, we just have to remember that we could have a positive square root or a negative square root that would be solutions to this equation. And so we can write this as plus or minus the square root of c. Now, when you're solving these for a test for me, you can write the plus or minus symbol. When you're actually entering them in WebAssign, you're going to have to enter them as separate answers. Okay, so just be aware. You'll have to enter the positive value, then a comma, and then the negative value, because there is no plus or minus button in WebAssign. All right, so let's take a look at this example here. So we've got x squared equals 5, and we want to find all the real solutions to that equation. All right, so if I want to solve for x here, what am I going to have to do? Take the square root of both sides. So we're going to take the square root of x squared, take the square root of 5. That gives us our x. And then what do we have to remember on the right-hand side now? Plus or minus. Good. So we're going to have a plus or minus square root of 5. We can't simplify the square root of 5, so that's going to be our answer this time. Okay? And again, just to show you why we need both, right? If I were to take these values and substitute them back into the original equation now, if I square the square root of 5, that's going to give us 5. But if I square negative square root of 5, remember when we square a negative, it becomes positive. And so this would also give us a positive 5. Right? So that's why we get two solutions to this equation, positive square root of 5 and negative square root of 5. All right, let's look at the next one now. So what are we going to have to do first to solve that equation? Okay, so we actually don't want to move the 5 here because we already have a form that's similar to the previous one, right? We have something squared. So we could distribute the square, right? We could actually expand out the x minus 4 squared, but we can actually solve this one the same way we solved the previous one. So if I want to get rid of that square, what would I need to do? Just take the square root of both sides, right? So I can do the same thing that I did on the previous problem and just go ahead and take the square root because I know that's going to cancel out the square. And so what's left on the left-hand side now? Just the x minus 4. Good. And just like before, we still have to remember our plus or minus. So this is going to give us plus or minus square root of 5. Right, now I still need to get x by itself. So then what can we do? Now we can add the 4. Good. So I'm going to add 4 to both sides. And so that gives me my x over here. And then typically we would write the 4 in front and then the plus or minus square root of 5. The order really does not matter here. Okay, so if you wrote plus or minus square root of 5 and then plus 4, that's fine too. Okay, so either one of those. But again, notice we have two different answers: 4 plus square root of 5, 4 minus square root of 5. So in WebAssign, if you wanted to enter this answer, you're going to do that and that. Because again, there is no plus or minus button in WebAssign. Any questions on that one now? Yeah, so if you have just a number on the right-hand side and you have a square on the left, the easiest way to solve those problems is always just going to be to take the square root of both sides. Because technically all the other suggestions are mathematically correct, right? They would work. We could expand it, we could move the 5 to the other side, all that stuff. But then we would have to look for another process to solve this one because it's still not going to factor at that point. And so if you just have something squared equals a number, just go ahead and take your square root, get rid of that square, move everything to the other side to get x by itself, and that's going to be your simplest way to get x by itself in that case. Any other questions there? All right. Now, completing the square. Okay, so this is another process that we can use to actually solve a quadratic equation. So first thing is if we have an x squared plus bx, if we want to turn that into a perfect square, we're going to use this formula right here, b divided by 2 squared, to create our c value that would then be able to be factored into a perfect square. Okay, so notice here we've got x squared plus bx. We're substituting this piece right here into that equation to fill in the c value. And then once we do that, then we'll be able to actually factor that into x plus b over 2 all squared. Now, this makes a lot more sense with actual numbers, okay? But just know what I boxed in there, that's the important part because that's the formula we're going to have to use to complete the square. All right, so let's try one. So we've got x squared minus 8x plus 13 equals 0. Okay, and we want to solve this by completing the square. Okay, now, the first thing we always want to do when we're completing the square is to get the x squared and the bx term by themselves, which means I need to move the 13. So I'm going to subtract 13 on both sides here. So now I have my x squared minus 8x. I'm going to leave myself some space here because I'm going to fill in a new c value using my formula. And that's going to be equal to negative 13. So first step, always move the C value to the other side first. Now we can use our formula. So now we're going to do the B divided by 2 squared formula. What's the B value this time? Okay, good. And it technically is a -8, right? So make sure you keep the sign with the number. So we're going to have -8 divided by 2 squared. Now we just need to simplify that. What's -8 divided by 2? -4. And -4 squared is +16. Good. So that gives us our new C value now. So in place of that blank space that I left, I'm going to put a +16. Now, keep in mind, whatever you do to one side of an equation, we have to do to the other. So I can't just add 16 there. I have to go to the other side and add 16 to the other side also. That's the step that a lot of people forget about. Okay, so just make sure when you add the 16 on the left, make sure you add 16 on the right. Any questions up to that point? All right, now we're going to factor. So if we look at the left-hand side, how could I factor x squared minus 8x plus 16? Good. So this is going to turn into x minus 4 squared, because it will be x minus 4 times x minus 4, which we can write then as x minus 4 squared. On the right-hand side, what's -13 plus 16? That's going to give us 3. Good. Now, just real quick, whenever you're factoring that x squared minus 8x plus 16, the easiest way to figure out how it's going to factor, we know it should be a perfect square because that's what we're doing is completing the square. If you look back at this step right here before we squared our value, that's the number that's always going to go in your parentheses. Okay, so in this case, we had that -4. That's the value that's going to go in our parentheses, x minus 4. And that's why I actually show the steps over here for simplifying, because if you can go back to that step before you squared, that'll tell you how that's going to factor every single time. Okay. Now, once we get it to that point, now we have a problem very similar to the last example that we did. What would we do next to solve this equation? Take the square root. Good. So I'm going to get rid of that square. So I'm going to take the square root of both sides. Again, that's going to cancel out the square and leave us with x minus 4. And then again, don't forget, we still need that plus or minus on the right-hand side. So plus or minus square root of 3. And then what's our last step going to be? Add the 4. Good. So that's going to give us +4 plus or minus square root of 3. And so this would be our solution to that equation. Now, the reason completing the square is useful, right, is if you look back at the original equation, 13, the only factors of that are 13 and 1. That's never going to give us an 8x in the middle, so there's no way to factor this problem. So we need another way to solve it, and completing the square is one of those ways that we can actually solve this for x now. Any questions on any of the steps for that first one? All right, let's look at the next one. So what's our first step going to be? We're still trying to complete the square here. Okay, so before we actually divide by the 3, okay, what do we always need to do first, right? What's that very first step that we did before? move the 6, right? So let's go ahead and move the 6 to the other side. So that's going to give us 3x squared minus 12x equals negative 6. Now, in this case, because we have a coefficient in front of our x squared, right? We have a number there, 3. We actually need to factor out that 3 before we complete the square, before we use our formula. So if I factor out the 3 here, what's actually going to be left from the x squared minus 12, or 3x squared minus 12x? Good. So we're going to have x squared and a minus 4x. Okay. So we have to do that because that's going to change that b value, and so we have to make sure we're using the correct b value when we use our formula now. So always factor out that coefficient if you have anything in front of the x squared. Now we can do our b divided by 2 squared formula. What's our b this time? Negative 4. Good. So we have negative 4 divided by 2 squared. Again, I'm going to simplify first, right? So what's negative 4 divided by 2? Negative 2. And what is negative 2 squared? Positive 4. Good. So again, that tells me what I'm going to put right here in place of my c value. We have a plus 4. Now, what else do we have to do? Okay, whatever we do to one side, we have to do to the other side. What did we add to the left-hand side? Be careful, right? We put a 4 in the parentheses, but what did we actually add to the left-hand side? We actually added 12 because that 3 that's on the outside would get distributed to the 4, and so we're actually adding 3 times 4 to the right-hand side. So we're adding 12. Okay? So whenever you do that factoring piece up front, just be very careful. When we add that number in the parentheses, it's getting multiplied by the number on the outside. So we're really adding that product to the other side now. Any questions on that step? All right, so now we can factor, right? So we have our x squared minus 4x plus 4. What is that going to factor into? Good. So again, we can look right here at this number. That's a negative 2. So that tells us we should have x minus 2 squared. Again, I keep the 3 out front, right? So don't forget to bring down your 3. And now if I simplify the right-hand side, what's negative 6 plus 3 times 4, or negative 6 plus 12? Should be positive 6. Good. Now, we have one additional step this time because we need to get rid of the 3 before we can take our square root. So what are we going to do with the 3 on both sides? Divide, right? Divide both sides by 3 first. It's going to give us x minus 2 squared. 6 divided by 3 is 2. And now we can take our square root, right? So we'll take the square root of both sides. That gives us our x minus 2. Again, don't forget your plus or minus. So plus or minus square root of 2. And then our last step is to do what? Good. Add the 2 to both sides. And so now we have x equals 2 plus or minus square root of 2. And this would be our answer. Any questions on any of those steps now? All right. Quadratic formula. Okay, so this is another way that we can solve specific quadratic equations that we cannot factor, right? So completing the square is one way that we can do that. Quadratic formula is another. So the roots of our quadratic equation, ax squared plus bx plus c equals 0, and a can't be 0, right, because then it wouldn't be quadratic anymore. We're going to have negative b plus or minus the square root of b squared minus 4ac all over 2a. That is our quadratic formula. Now, my teacher back in high school taught me a little tune to help me remember the quadratic formula, so I will sing it to you. Bear with me. But that helps me to remember it. I haven't forgotten it. So if it helps you, great. If you have another song or way that you remember quadratic formula, please use it. But the way I learned it was negative b, plus or minus square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. And so the Farajaka tune, right, it always stuck with me. I could always remember the quadratic formula that way. So whatever you need to use to help you remember it, right, just find a way to remember this formula. Again, all we're doing is taking the coefficients a, b, and c, and we're substituting them into that formula, and that's how we're going to solve. All right, so let's take a look here. I left out a number here. Let me make sure I have that correct. This first one should have a -1 in it. Let me fix that. There we go. Okay, so 3x squared minus 5x minus 1 equals 0. All right, so again, we're going to use quadratic formula this time. So our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so if we're doing that for this first one here, what's that first term going to be? It's going to be a 5, right? Negative 5 becomes a positive. So we're going to start with positive 5. Plus or minus the square root. Then we're going to take that b value and we're going to square it, right? So it's a negative 5 squared minus 4 times, what's our a value? 3. And then what's our c value? Okay, and make sure you keep the value, right, the sign in front of the number here, so that's going to actually be a -1. Those signs are going to be important to determine whether we're actually adding or subtracting. Okay, so keep the minus with the 1. All over 2 times a, which we already said was 3. Any questions just on the substitution piece of that one? All right, now we have to simplify. So when I come inside my parentheses now, we're going to have 5 plus or minus the square root. What's negative 5 squared going to give us? Positive 25. Good. And then we have a -4 times 3 times -1. So what's that going to give us? It's going to become a positive 12, right? So we have a -4 and a -1. That becomes a plus 12. And then all over 2 times 3, which is 6. Good. Right, and then the last thing here, and then we'll see if we can simplify, right? But we can add together the 25 and the 12. So we're going to have 5 plus or minus the square root of 25 plus 12 should give us 37 all over 6. Now, always look at your square root, see if there's anything that we can bring out. So are there any perfect square factors of 37? Anything that I can break that down into? There's not, right? Okay, so you would kind of go through your list, right? 4 doesn't go into 37, 9 doesn't go into 37, 16 doesn't go into 37, and you can actually stop there, right? 25 doesn't either, and 36 obviously doesn't. So in this case, that is a prime number, actually, 37. So we can't break it down any further. These are the solutions to that quadratic equation now. And again, you always want to look for those perfect squares, see if any of them are factors of the number underneath, because if so, then we need to bring out what we can and then see if we can simplify that fraction any further. Any questions at all on that first one now? All right, let's look at the next one. So same formula, right? So we're going to have x equals, what's negative b going to give us? Negative 12, good, plus or minus the square root of, then we're going to do b squared, so that's just 12 squared, minus 4 times, what's our a value this time? 4, and our c value is 9. Good. All over 2 times a, so 2 times 4 again. All right, now we're just going to simplify all of that. So we have x equals negative 12 plus or minus the square root of, what's 12 squared? 144. And now if we multiply negative 4 times 9, what should that give us? Okay, good. A minus 144. All over 2 times 4, that's just going to be 8. Now this time, when we combine what we have inside the square root, what are we going to have now? A 0, right? And so we're left with negative 12 plus or minus the square root of 0 over 8. Well, what's the square root of 0? It's just 0, right? So really now we have negative 12 plus or minus 0 over 8. Well, if I add 0 or subtract 0 from negative 12, what am I going to get in both cases? Negative 12, right? It doesn't matter if I add 0 or subtract 0, I'm still going to get negative 12. So I really only have negative 12 over 8 in this case. And then we always want to look to see if we can simplify our fraction. Okay, what would negative 12 over 8 simplify to? Good, negative 3 halves, right? Because 4 goes into both of those. If I divide 12 by negative 4, I get negative, or negative 12 by 4, I get negative 3, and 4 divided by, or 8 divided by 4 should give us 2. Notice here, we only got one solution this time, right? So negative 3 halves is a single value. It's the only value that works, and it's because we got that 0 inside of our square root this time. Okay, so whenever you get a 0 inside there, you're only going to get one solution to your quadratic equation. Any questions on that one now? All right, so get the third one. Same process, x equals. What's that first piece going to be this time? -2, good, plus or minus the square root of, and we're taking that same b value and squaring it, so that's 2 squared minus 4 times, what's our a value this time? 1, right? So if there is no coefficient in front of the x squared, it's an understood 1. So our a value is 1. And then our c value is what? +2. Good. All over 2 times a, which we already said was 1. All right, so now let's simplify that. We've got our -2 out front, plus or minus the square root. All right, what's 2 squared? +4. -4 times 1 times 2 is going to give us what? -8. And then 2 times 1 in the denominator should be 2. All right, now if we simplify what's under the radical there, -2 plus or minus the square root of, what's 4 minus 8? -4 all over 2. Now, what do you notice here? We have a negative inside the square root, right? So far, based off of real numbers and everything that we've talked about, can we take the square root of a negative value? We cannot, right? And so in this case, right, they only wanted us to find all real solutions. And so what we would have to say here is there are no real solutions. And so since we get a negative value inside of our square root, we can't get a real value out of that. And so we would say there are no real solutions to this equation. Now, eventually, we will get to other types of numbers that are not real that we can actually give some solutions to this. Okay, they won't be real solutions, but they will be solutions. Right now, that's all we have to say. Any questions on that one? All right. So now, this slide basically kind of summarizes what we just looked at. Okay, so b squared minus 4ac, this piece right here, is what we call the discriminant. Okay, that is the piece that's under the square root. So if you remember your quadratic formula, b squared minus 4ac is the stuff inside the square root. If that discriminant is greater than 0, meaning it's a positive value, then we're going to have two distinct real solutions. That's like the first one that we did, right? We got a positive value inside, and we got two different solutions. If that discriminant equals 0, like the second one that we did, then we're going to have exactly one solution, right? And that's where we got the -3/2. If that discriminant is less than 0, meaning it's negative, then we're going to have no real solution to that one. So basically, you could just look at the b squared minus 4ac piece and determine before using the entire quadratic formula whether you have two solutions, one solution, or no solutions. So that's why the discriminant is useful, right? Now, honestly, for me, I rarely use the discriminant. I usually just go ahead and substitute everything into the quadratic formula. And then once I start to simplify it, if I recognize that I have a negative in there, I'm like, okay, yeah, there's no real solutions. Or if I notice that everything's going to cancel out inside the square root, then I know it's going to work down to one real solution. But you could just focus on the inside piece there if you wanted to know how many solutions you're going to have. All right, so we're going to skip over example 8 and 9. We're going to go to example 10. Okay, so we want to solve this equation now. All right, now to solve this equation, the first thing I'm going to want to do here is let's see if we can get rid of these fractions, right? Because especially since we have the x's in the denominators here, if there's a way that we could somehow get rid of the fractions, it would make life a lot easier. So to get rid of the fractions, the first thing I'm going to have to know is what is the common denominator between all the fractions, so then I can find something I can multiply by that would cancel out all my denominators. Let's focus on the right-hand side first. X squared minus 9. Is there anything I could do with that denominator that would help us to find a common denominator between all three of our fractions here? Factor it, right? So how is x squared minus 9 going to factor? Good. It's a difference of squares, so we're going to get x plus 3 and x minus 3. So I'm going to rewrite this now as 3 over x minus 2 over x minus 3 equals negative 12 over x plus 3 times x minus 3. All right, now, looking at all three of those fractions now, what could I use as the common denominator between all three fractions? Good. So we need the x, we need the x minus 3, and we need the x plus 3. So that's going to be the common denominator that I use. Now that I know that, I'm going to multiply every single term, both sides of my equation, by that common denominator. So I'm going to take this first fraction right here, and I'm going to multiply by x times x minus 3 times x plus 3. I'm going to do the same with this one right here. Multiply by x times x minus 3 times x plus 3. And then we have to do the same thing on the other side. Multiply here by x times x minus 3 times x plus 3. So again, first step, find your common denominator between all of your fractions, and then we're just going to multiply both sides of our equation by that, right? Because that's a property of equality. We're allowed to multiply both sides by the same thing. Now, if I do that, let's look at this first term. If I multiply 3 over x times x minus 3 times x plus 3, what's going to cancel out? The x, right? Because I'm going to have an x in the numerator, I'm going to have an x in the denominator, so I can cancel out the x's, which means I'm still left with everything else that I've got there. So I'm going to have a 3 times x minus 3 times x plus 3. Any questions on how I got that? Okay, so look at the next term. If I take the 2 over x minus 3 and I multiply it by that common denominator, what's going to cancel out? The x minus 3 factor, right? So I can cancel out that factor there. And so again, I'm left with everything else that's there. Notice here, this was a minus, right? So this is going to be a negative 2. Then we have an x and an x plus 3. All right, now we have our equals. Now we look at the right-hand side. Again, I'm going to see what cancels out here. So what factors can I cancel? Good. This time, the x plus 3 cancels, and the x minus 3 cancels. And so what's left on that right-hand side now? Good. So we have a negative 12 and we have the x, right? So it's going to be negative 12x. All right, before we move on, are there any questions at all about what I just did in that previous step? Good. All right, so now we need to actually solve this equation. So what are we going to have to do next if we want to solve this? Now that we've gotten rid of all of our fractions. Yeah, we've actually got to multiply all this stuff out, distribute what we can, combine like terms, right? And then we can solve from there. So let's look at this first piece, 3 times x minus 3 times x plus 3. I'm going to focus just on the x minus 3 times x plus 3 first. What would I get if I multiply x minus 3 times x plus 3? Good. Okay, we get x squared minus 9. That was that difference of squares that we started with, right? And that makes sense because that was what we factored it into. Then we can distribute the negative 2x to the x plus 3. So if I do that, what are we going to get? Good. Negative 2x squared, and then a minus 6x. On the right-hand side, we still have the minus 12x, so I'll bring that down. Now we can distribute the 3, right? So that's just going to give us 3x squared. 3 times negative 9 is negative 27. Bring everything else down. Right, and so now what can we do now that we've distributed everything? Combine like terms. Good. So if I do that, what are we going to get? Okay, good. So 3x squared minus 2x squared is x squared. We have our minus 6x minus 27 equals negative 12x. And now notice we have a quadratic equation, right? We have an x squared in there. So what are we going to want to do with this to solve it at that point? Okay, let's move the 12x over first, right? So add the 12x and we can combine it with the negative 6x. So when we do that, that's going to give us x squared plus 6x minus 27 equals 0. Now, we could complete the square, right? That's one way we could solve it. We could use quadratic formula, right? Or if it factors, we could factor. Can we factor this one? Yeah, right. So that's going to be our best bet and the easiest way to do it if it works, right? So let's go ahead and factor this one. What are the factors going to be that would give us x squared plus 6x minus 27? Good. X plus 9 and x minus 3. All right, now that we have our factors, now we can do what? Okay, and how do we solve? Good, so each one of those factors equal to 0. So we have x plus 9 equals 0, or x minus 3 equals 0. And so what are the two solutions going to be here? Good, x equals -9, or x equals +3. Now, with a problem like this, where we started with rational expressions, meaning we had x's in the denominator, we have to go back to the original equation and check our solutions. And the reason is, when we eliminated the fractions, it's possible that we introduced values for x that don't actually work in the denominators of what we started with. Okay, and so we have to make sure that the values that we just got will actually work here. Basically, you're just trying to make sure that nothing's undefined, that you never get a 0 in the denominator. Okay, so I'm going to start with a -9, and I'm going to substitute it back into the original equation that I had up here. So that's going to give me 3 over -9 minus 2 over -9 minus 3 equals -12 over -9 squared minus 9. Now, I'm not going to take the time to actually go through and simplify all that and check, make sure. Again, all I'm really looking for is, do I end up with any zeros in my denominator? Okay. Will any of those values give you 0 in the denominator this time? No, right? And so in this case, this one checks out. -9 is a solution to that equation. So as long as we don't get 0 in the denominator, okay, we can assume there that that's going to work. Now let's look at the 3. Okay, so I'm going to have 3 over 3 minus 2 over 3 minus 3, and then -12 over 3 squared minus 9. Will any of those give us 0 in the denominator? Yes, right? The 3 minus 3 would make that undefined, and the 3 squared minus 9 would also be 0. That's undefined. And so because those are undefined, that tells me that 3 doesn't actually work. So the only solution to this equation now is the -9. So that's why we have to go back and check, because if you get 0 in the denominator of the original equation, then we can't actually include those values in our solution. Any questions on that now? All right, so that's where we're going to stop for today. We'll pick up and finish up 1.5 tomorrow for sure, and probably get into 1.8 also. Continue to work on that homework, though. Send me those questions as you got them. Feel free to drop in during student hours. But otherwise, have a great afternoon, and I will see you all tomorrow.